All right, so today we're going to talk about slope. So I want you to take for a second, think about the word slope. When you think about the word slope, what is it that comes to mind? For me, what comes to mind is skiing, right? Going to the slopes and skiing, right? So then if you think about that, slopes are measured by steepness, right? So that is actually what slope is. Slope is how steep something is. So today we're going to talk about the slope of lines. So we're going to focus on the steepness of a line. All right, so slope is the steepness of a line. Hopefully, you've been noticing that as you have been graphing your lines, that every point that you graph, there's the same distance between every point. That distance is your slope, right? The way that we measure that distance is we count what we call the rise over run. Now, when we're talking about slope, we use the letter M. So underneath your definition, let's write that. M stands for slope. I just looked up why is it M for slope because I get that question all the time. Turns out there's lots of theories, but nobody is actually really sure why we use M for slope. But whenever you see M, we're talking about slope. We measure the slope by counting the rise, how far up or down we go, over the run, how far left or right we go, to get to the next point, right? So what we do is the directions are here, but when we are finding a slope of a line, we choose two ordered pairs or 2 points on the line, and then we pick one of those points and we count how far up or down we have to go to get to the next point, and then how far left or right we have to go. So if you think about that, the rise, it's called rise because you think going up, but it could also be a fall, right? Rise or fall. So I could go up or down. So the top number is representing how far up or down we go. So I want you to write that, up or down. Now, if you think about it, when we're thinking about the X and Y axis, up is actually the Y axis, right? When you go up, we're talking about Y. When you go left or right, we're talking about X. So think about for your rise, if I go up, is that positive or negative? Well, if I go up, that's going to be a positive number. If I go down, that's going to be a negative number. Now, the bottom number of your slope is your run. And it's run because if you think about running, you're going to be running horizontally. So that is how far right or left you go. So think about the x-axis. If you go right on a number line, that's positive. If you go left on a number line, that's negative. So another way to think about slope is we could also say it's the change in y over the change in x. And we'll talk about more about that one in a minute. You might also see that it is called delta y, and we represent delta with a triangle over delta x. And the delta symbols are talking about the word change. So it's like it means the change in y over the change in x. So let's go ahead and try some of these. All right, so if I'm looking at line A is this line right here. What I need to do first is I need to start locating my ordered pairs, my whole number ordered pairs, my solutions on the line, right? So remember, when you're graphing ordered pairs, if you have a whole number ordered pair or an integer ordered pair, they're going to end up in the corners, right? So if I'm looking at this line, I'm looking for my corners, right? So right there is a point, right? All of these are all fractional solutions here. This one is a point. Keep going, keep going, keep going. This one is a point, and keep going, keep going, keep going. And then this is a point. So let's go ahead and mark some of those. So let's just mark all of them. And you should start to notice that all of these points are the exact distance away from each other. If they're not, then you're not marking them correctly. Okay? So now you're going to do what I kind of call a slope triangle. And you can draw it or you can count it. But you're going to go up or down first, and then left or right to get to the next point. It does not matter what point you pick, right? So let's say I'm going to start down here at the bottom, right? So I'm going to start here, and I'm just going to say, all right, how far up do I have to go? So I'm going to draw a line. Okay, I'm going to go up, and then how far to the right do I have to go? And then you're just going to count it, right? So I start here, I'm going up 1, 2, 3, 4. So that means that my rise is 4, and then my run, I go from here to here, is 1. So my run is 1, right? So I would write my fraction, and you don't have to write this down right now, just listen. I'm going to now say, okay, so my slope is 4 over 1. Now 4 over 1 is not fully simplified. 4 over 1 is just equal to 4. So my slope would be 4. Now, suppose we started at a different point. Would I still get 4? The answer is yes, right? Suppose I started here, and I decided to count from here to just the next immediate point. If you count it, you go up 4 and to the right 1 again. All right, what if instead of going up, I decided to go down first? Is that allowed? Sure, but you just have to think about it. If I start here, let's say I'm starting here where the green is. If I go down first, you still are going down 4, but you have to keep in mind that when you go down, down is a negative direction. So you would have to say it's negative 4. And then you go left, and you have to remember when you go left, that's a negative direction. So that would be negative 1. So then it would be negative 4 over negative 1, which still equals 4. All right? Now, suppose you didn't find all the points that were right next to each other. Let's take a look at the points in black now that I'm about to put here. Suppose when you were doing it, you found that point, and then you found this point, and then you count it from here down at the bottom all the way up here. Well, is that still going to give me 4? Well, if you count it, take a look. I'm starting here. I'm counting up. I'm going up 1, 2, 3, 4, 5, 6, 7, 8. So now my rise is 8. And then my run from here, you count over 1, 2. Oh, well, that's still 4, right? Because what's 8 over 2 equal to? So no matter what, my slope is going to be 4. So right in the box here, we're going to say that m is equal to 4. Let's go ahead and take a look at the next line. All right, line B. Line B is right here. Now, if you think you really got this, stop the video and try to find your points and go ahead and do it. But I'm going to do all of these with you before I set you out on your own. All right, so going through, finding my lines, I am looking down my line, and I'm already seeing where they intersect. Right here is a line, right? Following it. There looks like there's one there. Looks like there's one here where they're intersecting. Looks like there's one here. I think I missed one. There's one up here at the top as well. So go ahead and put in your points there, and then count your rise over your run. Now, if you're getting all your points and you go from the closest point to the closest point, you're going to get the most reduced slope anyway, right? So taking my slope triangle, let's say I'm going to start right here where I'm putting the red dot, and I'm going to go to the next one where I'm putting the next red dot, and you just count, right? So I'm going up 1, 2, 3, to the right 2, 1, 2. So here I get 3 over 2, right? Make sure you always put your rise on the top and your run on the bottom. Just a quick refresher, it doesn't matter if I started here and I went down, that would give me negative 3 over negative 2, and a negative over negative is a positive, right? If I didn't find points that were closest together, let's say I started from here and I went down 6 and to the left 4. Well, if you think about that, negative 6 over negative 4, a negative over a negative is still a positive, and 6 over 4 still reduces to 3 over 2. So the slope is going to be 3 over 2. So here you're going to write m is equal to 3 over 2. All right, let's move on to the next line. Line C. Line C is here. So I am going through and I'm seeing a point right there, point right there, point right there, point right there, point right there. Go ahead and put in your points and try counting your rise over your run. I'm going to go ahead and put my points in red here. and then we're going to start counting. Now, I'm going to start where I'm putting a black dot. Let's say I go like this. And I want to start from this point, and then I'm going to go to the next point where they intersect, right? Well, I'm going to think I want to rise first. So be thinking rise over run, right? The way you calculate slope is the exact opposite of the way that you actually graph an ordered pair, right? So it's the change in y. So you rise first. Well, I'm just going to rise 1 there. And then now I'm going to the left. 1, 2, 1, 2, 3, 4, right? Now, because I went left, however, that's negative. So that's -4. So my rise for this one is 1 over -4. And you know how I don't like negatives in the denominator. So if you think about it, this is a positive number divided by a negative number, and a positive number divided by a negative number is just a negative number. This is an example of something that has a negative slope. So this you would rewrite as -1/4. Now, that negative sign can go on the top, or you can write that negative sign right out front. We typically don't leave our negative signs in the denominator, so pull it out to the front. Show me that this is a negative fraction, right? So the slope here is -1/4. Now, if you had picked any other point, you're still going to get -1/4, right? So just quick reminder, I'm going to put some blue dots in here. So let's say I start at this point, and let's say I missed the point in the middle and I went from here, right? So that would mean I'm going to go down and to the right. So you're always, when you're making your slope triangle, it's always going to be a right angle, right? And then you just count. Suppose I went down. Remember, when you go down, that's down 2. That would be -2. And then you go to the right. Well, that, going to the right, if you count that, starting here, it would be 1, 2, 3, 4, 5, 6, 7, 8. So that would be over 8. So that would be -2 over 8, which you would have to reduce, which means that my slope here is going to be -1/4. So let's go ahead and write that in there. M here is -1/4. Let's move on to the next one. All right, now looking at line D. Line D is this line right here. So go in and start putting in your points here. These points are a little bit further away from each other. I see one here. I see one here. I see one here. Go ahead and put in some of those points and then calculate your rise over your run. Again, it doesn't matter which direction you go first, right? If you choose to go up first, I'm going to start here on the y-intercept. I'm going to go up, count, I'm going up 4, and then left 5. You have to remember, up is a positive direction, left is a negative direction. So this would be 4 over -5, which I don't like that negative in the front. So I would make it, the slope is -4/5. Again, if I chose to go down, it would be whoops, I went down too far, -4, because that's down, to the right 5, you still get -4/5. So the slope for this one is -4/5. All right, moving on to the next one. Now, line E. Line E is a horizontal line, right? So if you look at line E, right here, line E, if you look every single point right here, this is a point, 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 right? So honestly, it doesn't matter which ones you use. Let's say I use this is a point and this is a point. Now, the tricky part about this one is I'm like, well, what is the rise? Well, remember, rise is how far up or down do I go to get to the next point. I don't go up or down at all. So the rise is 0. And then the run, it depends on what you choose, right? My run could be 1, 2. Your run could be 1. It could be -1. It could be -2. It could be -3. It could be 20, right? So my run, if I'm going direct route, would be like 0/1. Now, 0/1, however, is equal to what? Think about that. What is 0 divided by 1? Well, that's just 0, right? So the slope of line E, you would have to say is 0. Don't leave it as 0/1 because that's not fully simplified. So now let's take a look at F. F is a vertical line right here. So now, again, similar to the horizontal line, one of our rises or runs is going to be 0, right? So if you think about this, all the points still are just 1 away from each other. It doesn't matter, however, how far we go, right? So my rise, no matter what, like let's say I start here, my rise is going to be 1. My rise could be 2. It doesn't really matter. But my run, we don't run left or right at all, so my run is 0. Now, this number, whether you write 1 over 0 or 2 over 0, doesn't matter. You have 0 in the denominator. So because you have 0 in the denominator, that means the slope of this line we say is undefined. It does not have a definition because 1 over 0 is not a number. So when we ever have a vertical line, the slope of the vertical line will be undefined because we have a run of 0. Now, go ahead and look at line A and B. Notice lines A and line B, they both have positive slopes. And then C and D, look at these lines. These guys all have negative slopes. That's pretty important to recognize, right? So when you're reading from left to right, if the line is going up, it's going to have a positive slope. If you're reading from left to right, if it's going down, it's going to have a negative slope. Okay? Now, horizontal lines like this, it doesn't matter where I put that horizontal line. I'm still going to have a rise of 0, which means that my numerator is 0, which means the slope will always be 0. When it's undefined, I'm always going to have a run that is 0. So all vertical lines, it doesn't matter where I put that vertical line. Since your run's 0, it's always going to be undefined. So now at the bottom, since A and B have positive slopes, we could probably justify and say that all positive slopes look like this. All negative slopes, like C and D, will look like that, go in that direction. All slopes of 0 will look like this, and all slopes that are undefined will look like this. Now, stop the video and find the slope of these 8 problems without my help, and then tune back in to make sure you did it correctly. Okay, there are your answers for 1 through 8. If for some reason you have one incorrect and you can't figure out what you did wrong, make sure you put a question mark by it to remind you to come ask me about it the next time you see me. So let's now talk about how to find slope between 2 points if you don't have a graph, right? Sometimes you won't have a graph, and you might be asked to find the slope between 2 ordered pairs like 7252 and 2003, right? You're not going to graph those ordered pairs and count it. So we have to have another method. So let's just go ahead and take a look at this one. If I'm doing the rise over run here, hopefully you can really quickly see that my rise is 3 and my run is 7. Therefore, my slope is going to be 3/7. Now, I want you to take a look at the ordered pairs that we're talking about here, right? So we went from -4, 2 to 3, 5. All right, so I want you to think about this for a second. We had talked earlier about how rise over run is just the change in y over the change in x. So let's go ahead and take a look. When I rise, right, rising is the y-axis, right? So let's look at the y values. The y values were 2 and 5. Well, let's think about that. If I'm going from 2 to 5, the difference is 3, right? So if you think about that, 5 minus 2 is 3. 2 minus 5 we could say is -3. We'll talk about that in just a second. But all you're doing is you're just subtracting the y values, and that will tell you what your rise is. Now your run, we went from -4 to 3. So if you think about, if I'm counting from -4 to 3, well, isn't there a difference there of 7? I could just do 3 minus -4. So all you have to do if you have 2 ordered pairs is you just have to subtract the y values and then subtract the x values. And the y always goes on the top. So let me just show you. I could have just taken 5, my y value, and my y value, and I could have done 5 over 2. Now you have to keep in mind, you have to go in the same order. Right now I just did the second ordered pair minus the first ordered pair. So now I have to go back to the second ordered pair and subtract the first ordered pair. So I'm going to now do 3 minus -4, which you could just automatically say is 3 plus 4. And if you think about that, 5 minus 2 is 3. And 3 minus negative 4, which is the same as 3 plus 4, is 3/7, right? Same slope. You could go in the other order. It doesn't matter what you choose, but you just have to be consistent. Whatever order you go on the top, you have to go in the same order on the bottom. So suppose I did 2 minus 5. Well, let's see what that is. 2 minus 5, well, that's negative 3. And then suppose I did negative 4 minus 3. You have to go in the same order. Negative 4 minus 3, well, that's negative 7. And then you just have to remember, well, that's not fully simplified because of the double negative. The double negative becomes positive, so you still get 3/7. So there is a formula that we use. And the formula, don't freak out, uses what we call x sub 1 and y sub 1. So the formula is this. The formula is m equals y sub 2 minus y sub 1, just write it down, I'll explain what it means in a second, over x sub 2 minus x sub 1. Okay, so the subscripts, those are not exponents. All that's doing is just saying, well, you've got two different y values. Y sub 2 is just take the second y value and subtract it from y sub 1, which is the first y value. So, for example, I could say the slope, when I use the slope formula, if I have two ordered pairs, I could call the first one x sub 1 and the second one the x sub 1 y sub 1, and then the second one I could call x sub 2 y sub 2. So basically, if I was x sub 1 here would be the negative 4, y sub 1 would be 2, x sub 2 would be 3, y sub 2 would be 5, right? So you're just subtracting these. And then again, it doesn't matter which one you start with. If you start with y sub 1, you could say y sub 1 minus y sub 2. But if you go in that order, you have to go in the same order, x sub 1 minus x sub 2. So that's just meaning take the first y value, subtract the second y value, take the first x value, subtract the second y value, or second x value. And then you get your slope. You just have to remember to reduce it. All right, so using the formula, letter A. If you want to stop the video and just try it, totally fine. I'm going to do it both ways for this first one. I could start with, okay, m is going to equal, let's subtract the y values. So I'm going to do 12 minus 8. Since I did 12 minus 8, I did the second order pair minus the first order pair, I have to go in that same order again. So now my x values are going to be 12 minus 4. And so I'm going to do 12 minus 4. And then 12 minus 8 is 4, and 12 minus 4 is 8. So I get 4/8, but I have to reduce that. The slope is going to be 1/2. Now, suppose I decided to go in a different order. Suppose I decided to go my first y value, which is 8, minus my second y value. Well, then I'm going to get m equals 8 minus 12. And I have to do the same order now. Then I'm going to do 4 minus 12. And I do the math there. Well, the only difference here is I'm going to get negative 4 over negative 8. And you have to remember that that still reduces to positive 1/2. So no matter what, you get positive 1/2. Let's go ahead and take a look at the next one. Now the next one is a table. You might be like, well, what ordered pairs do I pick? It doesn't matter. Pick whichever ordered pairs you want. If you want to stop the video and try it, go for it, or just listen. I'm going to go ahead and say, I'm going to choose negative 5, 5, and negative 12, 19. It doesn't matter, right? You just have to remember that on the top, you are subtracting the y values, and the y values here are these two numbers. I always like to start doing the smallest or the biggest from the smallest, just because. So I'm going to do 19 minus 5. So since I did this one minus this one, you have to go in the same order. So the bottom's going to be negative 12 minus negative 5. Now don't let that mess you up. Minus negative 5 is the same as plus. So if you wanted to write negative 12 plus 5 there, that's totally fine. So what you get here is 19 minus 5 is 14, and negative 12 plus 5 is negative 7. Now you're not fully simplified. 14 over negative 7 does give you negative 2. If you picked two other ordered pairs, you should get negative 2. If you don't believe me, try it. Let's take a look at letter C. Letter C. On the top, I'm going to subtract my y values. So my y values are 2 minus negative 12. I'm just going to say 2 plus 12 because it's minus a negative, because I did the first minus the second, I got to do the first minus the second on the bottom. So now I'm going to do negative 6 minus negative 6. Now negative 6 minus negative 6 is the same as saying plus 6. So what I get here is 14 over 0. Uh-oh, red flag. If you have 0 in the denominator, that's a problem. What this actually means is that we have a vertical line, right? Our run is 0. So the slope here, we have to say m is undefined. Whenever 0 is in the denominator, it is undefined. Okay? Let's take a look at the next one. The next one, you have a table. Doesn't matter what two ordered pairs you pick. I'm going to pick the last two, right? On the top, you got to subtract your y values. They're both 62, so you get 62 minus 62. That means on the bottom, you don't know what order I went in. It doesn't matter. I'm going to do 10 minus 5. So 62 minus 62, well, that's 0. 10 minus 5 is 5. You have a 0 here. 0 is in the numerator. This is a horizontal line. 0 over 5 reduces to 0. Here, the slope is equal to 0. All right, let me know if you have any questions or mark anything you were confused about.